Hello everyone, we are going to solve the electrolysis questions of the IGCSE Chemistry 0620, starting from March 15. The first question, the aluminum and the iron are extracted from their ores by different methods. Aluminum is extracted from its purified oxide ore by electrolysis, and this is the apparatus. The first question, what is the name of the ore of the aluminum, which consists mainly of the aluminum oxide? Actually, it is the bauxite. The second question, the electrodes are both made up of the same substance. Name this substance. It is the carbon in a form of graphite. Actually, the electrodes usually are made up of graphite or platinum, but we choose the graphite because it is much cheaper. Aluminum oxide is dissolved in molten cryolite before it is electrolyzed. Give two reasons why the aluminum oxide dissolved in molten cryolite is electrolyzed rather than molten aluminum oxide alone. Actually, the cryolite, the first thing, it lowers the melting point of the mixture, and this lowers the energy cost. And it makes the mixture better electrical conductor. You have to know that the cryolite is sodium aluminum fluoride, Na3Alf6. And it is used for these reasons: to make the temperature, the operating temperature decreases from 2000 degrees Celsius to 900 degrees Celsius. And this will lower the energy cost, as we said, and the mixture will be better electrical conductor. And moreover, the cryolite acts as a solvent. Don't forget this. What happens to the ionic equations for the reactions at the electrodes in this electrolysis? Actually, the anode is the positive electrode, so the oxide ion in the aluminum oxide will be attracted to the positive electrode because unlike a charge attract, and it will be discharged by losing 4 electrons to change it to oxygen molecule. At the cathode, the aluminum ions will be attracted to the negative electrode from the aluminum oxide, and they will be discharged by gaining 3 electrons to return back to aluminum atom. So don't forget that the ions are attracted to the electrodes to be discharged, to become an atom again. The next question. The zinc produced by this process is impure. It can be purified by the electrolysis using a method which is similar to the purification of copper. Under the conditions used in the process, zinc is the product at the negative electrode cathode. Complete the following description of this purification. The something that I want to say that during the purification of copper, we electrolyze the copper sulfate solution, and we put the impure copper at the anode and the pure copper rod at the cathode. What happens at the anode that the copper will lose mass because the copper atoms change to copper ions. Let me mention that the electrodes in this process are reactive, made up of copper. And at the cathode, there is pure copper rod that will be heavier and increases in mass because the copper ions will be attracted to the pure copper rod and discharged by gaining electrons and change to copper atoms. So there is copper deposition at the electrode. And the electrolyte is aqueous copper sulfate, which is blue in color. Actually, the blue color will not fade because the concentration of the copper ions stays the same. They are formed at the anode and deposited at the cathode with the same rate. So this is why the blue color will not fade. So this process is similar to the extraction or the purification of zinc. So the electrolyte is aqueous zinc sulfate instead of copper sulfate. The negative electrode cathode is made up of pure zinc instead of pure copper. and the positive is impure zinc, the equation for the reaction at the cathode is the zinc ions will gain electrons to change it to zinc atoms because the cathode is the negative electrode, so the positive ions will be attracted to it. At the anode, the zinc atoms will change it to zinc ions by losing 2 electrons. Why the concentration of the electrolyte doesn't change? Actually, because the concentration of zinc ions will not change as zinc ions removed and formed with the same rate. The next question. The diagram shows the electrolysis of molten lithium bromide. While electrolyzing molten ionic compound, you have to know that we have only 2 types of ions, the cation and the anion, just the 2 types of ions, no more. There is no water. So the only ions we have, the lithium ion and the bromide ion. The first question, mark on the diagram the direction of the electron flow. Actually, the electrons move away from the negative terminal of the cell towards the positive terminal because they are negatively charged. So this is how the electrons move through the wire, like this, away from the negative towards the positive. The next question, write an ionic equation for the reaction at the negative electrode. Actually, the lithium ion will be attracted to the negative electrode and will be discharged by gaining 1 electron to change it to lithium atom. The ionic equation at the positive, actually the bromide negative ion will be attracted to the positive. So 2 bromide ions will lose 2 electrons to change to bromine gas. The bromine is diatomic. Next, which one is oxidized? Actually, oxidation is electron loss. So the one that lost electrons is the bromide ion. And the explanation because oxidation is electron loss. It lost electrons. Maybe you can say that there is increase in the oxidation state because the oxidation state of the bromide ion changes from -1 to 0. So this is rise or increase in the oxidation state. When aqueous lithium bromide is electrolyzed, a colorless gas is formed at the negative electrode and solution becomes alkaline. Explain these observations and include an equation in your explanation. Now we have water with the lithium bromide. Aqueous means dissolved in water. So there are 4 ions, the lithium and the bromide, and the H plus of the water, and OH minus of the water, hydroxide negative ion. Lithium and the hydroxide will be attracted to the cathode, the negative electrode. And the one that will be discharged is the H plus because it is less reactive, forming a hydrogen gas. Lithium ion will not be discharged. Br negative and OH negative will be attracted to the anode. The one that will be discharged is the Br minus because it is the halogen. The OH will not be discharged, forming a bromine gas and the anode. The ions that are not discharged, the lithium and the hydroxide, will remain in the beaker. So this is alkaline solution lithium hydroxide. So the first thing, hydrogen gas formed at cathode, and the ionic half equation, 2H plus will gain 2 electrons to form the hydrogen gas. Next, the bromine gas is formed at the anode. Which is brown gas. The ionic half equation, 2Br minus 2 electrons will form a bromine gas Br2, and the alkaline solution is lithium hydroxide. The next question, electroplating steel objects with silver involves a three-step processes. These are the three steps. We have to mention in electroplating means coating a metal with a layer of unreactive metal using electrolysis. So there are three tips that you shouldn't forget about electroplating. The first thing, the metal that will be coated, should be the negative, should be the cathode. And the metal used in coating for example, you want to coat it with copper, so we have to put a copper rod at the positive. It should be the anode. And the electrolyte should be salt solution of metal used in coating. For example, if you want to coat the metal with copper, so the electrolyte must be copper sulfate or copper nitrate solution. So there are three steps: coating of copper applied to the object, coating of nickel, and then coating of silver. A diagram of the apparatus used for step 1 is shown. This is the first step, to coat it with copper. The chemical process taking place on the surface of the object is, and here is the equation. Explain whether this process is oxidation or reduction. Actually, there is electron gain, and electron gain is reduction. Don't forget the three things about oxidation and reduction. Oxidation versus reduction. Oxidation is electron loss, but reduction is electron gain. Oxidation means increase in the oxidation state, and reduction means decrease in the oxidation state. Oxidation means gaining oxygen, or reduction means losing oxygen. So this is electron gain. So this is reduction, because Cu2 plus ion gained electrons. Explain why the concentration of the copper ions in the electrolyte remains constant through step 1. Actually, the copper ions are formed at the anode, and then it is removed from the solution at the cathode with the same rate. This is the explanation. So the copper ions, Cu2 plus ions, are formed at anode with the same rate of removal at cathode. So this is why the concentration of the copper ions didn't change. Give two changes which would be needed in order to coat NaCl onto the object in step 2. Actually, we have to do two things. We have to replace the copper rod with NaCl 1. Replace copper rod with NaCl. And we have to change the electrolyte. Instead of copper sulfate, we have to put NaCl sulfate solution. The next question. What is meant by electrolysis? Electrolysis is breaking down molten or aqueous ionic compounds, molten or aqueous ionic compounds by passing electricity. So don't forget that this process is really important to decompose the ionic compounds, and they must be molten or aqueous to allow the ions to move freely. And we do this by passing electricity. Actually, the compound will change to elements. We break down the compound into elements. Name a substance that can be used as inert electrodes. As we said before, the electrodes are made up of carbon in a form of graphite or platinum, because both of them are a good conductor of electricity and inert. Write an ionic half equation for the reaction in which hydrogen is produced. So the hydrogen positive ions will gain electrons to form the hydrogen gas H2. Actually, the hydrogen ions are positively charged, so they will be attracted to the negative electrode, to the cathode. To test the chlorine gas, we have to bring damp blue litmus paper because the chlorine has an acidic effect. So we have to bring damp, and it should be damp to allow the chlorine gas to dissolve with the paper. So damp blue litmus paper. At the start, the paper will turn red at start, and then it will be bleached. Bleached means it becomes colorless. Next, the copper sulfate solution was electrolyzed using the apparatus shown. While electrolyzing copper sulfate, you have to focus whether it is made using carbon electrodes inert or copper electrodes reactive. In this diagram, there are carbon electrodes, so it is inert. A gas was formed at the anode. Identify this gas and give the test for this gas. Actually, in this solution, copper sulfate, we have 4 ions, Cu2+, H+, sulfate SO42-, and OH-. The negative ions will be attracted to the anode, the positive electrode, but the hydroxide, it will be discharged, not the sulfate, forming oxygen gas, which is a colorless gas, and the copper and the hydrogen will be attracted to the cathode. The one that will be discharged is the one which is less reactive, which is the copper, forming copper deposits on the cathode. So what is the gas? Oxygen. The test of the oxygen gas is glowing splint. The result that it will relight again. During electrolysis, electricity passes through copper sulfate solution. Solid copper sulfate doesn't conduct electricity. Explain both of these statements. Actually, the ionic compounds in the solid state, its ions cannot move freely because they are held together with strong electrostatic attractive forces, so they cannot move. But when they are molten or aqueous, the cations and anions can move freely, so they can conduct electricity. So solid copper sulfate has no free moving ions. But aqueous copper sulfate, its ions can move freely to conduct electricity. The electrolysis was repeated using copper electrodes in place of carbon electrodes, and the ionic half equation for the reaction of the 2 electrodes are shown. Don't forget that in the reactive scenario, you have to know that the anode is made up of impure copper and the cathode is made up of pure copper. What happens at the anode that the copper atoms change to copper ions, and then it will be discharged and removed from the solution, the cathode changing to copper atoms. So the anode loses mass and the cathode becomes bigger. And the concentration of the solution didn't change, and the blue color remains because the rate of the formation of the copper ions at the anode equal to the consumption of the copper ions at the cathode. They happen the same rate. So which species is reduced during the electrolysis? As we said before, reduction is electron gain. So Cu2 plus is reduced because it gained electrons. The masses of the electrodes change. State how and explain why the masses of the two copper electrodes changed, and use the ionic half equations. The anode loses mass because the copper atoms loses electrons, changing to copper ions, so it dissolves. The cathode, it gains mass, its mass increases because the copper ions will be attracted to the cathode and discharged to change to copper atoms. So there is copper deposition or deposits on the cathode. Why during the electrolysis the color doesn't change? Because the rate of formation of copper ions at anode equal to the rate of removal of copper ions at cathode. So the copper ions are formed at the anode and removed at the cathode with equal rate. This is why the blue color of the solution remains and doesn't fade. In this question, we have to write all the details about the extraction of the aluminum and the ionic half equation at each electrode. Firstly, the ore of the aluminum oxide, as we said before, it is the bauxite, which contains impure aluminum oxide. So this bauxite should be dissolved in molten cryolite to lower its melting point from 2000 to 900. And to make it better electrical conductor, then the molten aluminum will be formed in the bottom of the container. Here in the extraction of the aluminum, the molten aluminum will be formed in the bottom because it is more dense than the mixture, and it will be formed at the cathode. And the anode, there are negative ions, oxide negative ions will be attracted to the anode, forming oxygen gas that will react with the carbon anodes, forming carbon dioxide gas. We will solve a question about this later. So the bauxite, as we said, should be dissolved in molten cryolite. To lower its melting point from 2000 degrees Celsius to 900 degrees Celsius. And for better conductivity, so the molten aluminum is formed at the cathode. The ionic half equation at the anode. Anode is the positive electrode. Don't forget this. So the oxide ions from the aluminum oxide will be attracted to the anode, losing 4 electrons to change to oxygen gas. And the cathode is the negative electrode. So the aluminum positive ions will be attracted to it and discharged by gaining 3 electrons, changing to aluminum atoms. Why the anodes must be replaced regularly? Because at the anode, oxygen gas is formed from the oxide ions. The oxygen gas will burn with the carbon anodes Don't forget that the anodes are made up of carbon because the temperature is very high, 900 degrees Celsius. So they will burn to form the carbon dioxide gas or carbon monoxide gas. It depends whether complete or incomplete combustion happens. So the carbon anodes, you have to say that the anodes are made up of carbon, burn with the oxygen, forming carbon dioxide gas. Concentrated aqueous solution of sodium chloride is electrolyzed. We have 4 types of ions because there is water, Na+, H+, Cl-, OH-. So what are the products at the positive? Cl- and OH- will be attracted to the positive electrode, but it is concentrated. So the halogen will be discharged and the OH will not be discharged, forming chlorine gas. Hydrogen and sodium ions will be attracted to the cathode, but the hydrogen will be discharged because it is less reactive. What is the ionic half equation at the negative? We said that hydrogen is formed at the negative, so the ionic half equation, 2H+ will gain 2 electrons to change it to hydrogen gas. A dilute solution of sodium chloride is electrolyzed using carbon electrodes, so now it is dilute instead of concentrated. So at the anode, which is the positive electrode, chloride and hydroxide will be attracted, but now the halogen is diluted. So there is no enough halogen ions to be discharged. So the hydroxide will be discharged, forming oxygen gas. You have to know that the hydroxide is discharged by losing 4 electrons to change to 2 molecules of water and 1 molecule of oxygen. This equation you have to know because it is really important. Molten sodium chloride, now we don't have water, it's only molten without water. So what will be formed at the negative? We have 2 ions only. Na+ will be attracted to the negative, forming sodium deposits. The ionic half equation at the negative, so the sodium will gain only 1 electron to change to sodium atom. Electrolysis of copper sulfate using carbon electrodes, which is inert. The first question, draw an arrow to show the direction of the movement of the electrons in the wire. The electrons, as we said, are negatively charged, so they will move away. They will be repelled by the negative terminal of the cell, and they're attracted to the positive terminal of the cell. We want to draw an arrow in the solution to show the direction of the movement of the positive ions in the copper sulfate solution. The positive ions will be attracted to the cathode, so they will be moving towards it. Oxygen was formed at the anode and copper was formed at the cathode. Write the ionic half equation for the formation of oxygen is shown. Explain why this is oxidation. Oxidation is electron loss. So because electrons are lost. Write the ionic half equation for the formation of copper at the cathode. The copper ions will gain electrons to change to copper atoms at the cathode. The electrolysis was repeated using copper electrodes. Now it is reactive in place of carbon electrodes. As we said, the anode loses mass and the cathode gains mass. And this is because at the anode, the copper atoms are changed to copper ions, and at the cathode, the copper ions will be changed to copper atoms. So the anode loses mass because copper atoms will lose electrons to change to copper ions. And those copper ions will be attracted to the cathode, which gains mass. Because the copper ions will gain electrons at the cathode, changing to copper atoms. Again, the extraction of the aluminum. Name the type of particle responsible for the transfer of the charge in the wires. Electrons carry the charge in the wires, and in the electrolyte are the ions. Why cryolite is used, as we said, for better conductivity. And it acts as a solvent and lowers the operating temperature from 2000 to 900. The ionic half equation for the formation of the aluminum is formed from aluminum ions that will gain 3 electrons to change to aluminum atoms. How carbon dioxide is formed at the anodes? Actually, there is oxygen formed at the anode from the oxide ions that will be discharged at the anode. Oxygen formed at anode from aluminum oxide. It will react with the carbon anodes forming carbon dioxide gas. So the anodes will break down and we must replace them frequently. What is meant by electrolysis? Actually, electrolysis is breaking down molten or aqueous ionic compounds by passing electricity through it. So we bring the ionic compound in the molten or aqueous state to allow the ions to move freely and pass the electricity through it. It will decompose or split into elements. The student observes bubbles of colorless gas forming at each electrode. Actually, this is the electrolysis of dilute sodium chloride. We have 4 ions because there is water. The sodium and hydrogen will be attracted to the negative, but hydrogen will be discharged because it is less reactive. Sodium will not be discharged. Chloride and hydroxide will be attracted to the positive, but the one that will be discharged actually is the hydroxide because it is dilute, no enough halogen ions. So the hydroxide will be discharged at the positive, forming oxygen gas. So the gas produced at the positive is oxygen. Describe the test for this gas. To test the oxygen, we have to bring glowing splint. It relights once it is contact with the oxygen. So what is the ionic half equation for the reaction taking place at the cathode? We said that at the cathode, the hydrogen will be discharged. What is the type of particles responsible for transfer of charge in wires? As we said before, electrons. And the electrolyte is ions. The student replaces the dilute solution with concentrated one. Actually, there are 3 observations that will happen that are totally different from the dilute one. The first one is that there is green gas will be formed, which is the chlorine gas at the positive. Because in this case, there are a lot of chloride ions, so the halogen will be concentrated. If the halogen is concentrated, it will be discharged instead of the hydroxide. The second observation, that the bulb will be brighter and there is more bubbling. The rate of bubbles will increase. The student has a small piece of impure copper and he wants to purify it. As we said, to purify the copper, you have to put the impure copper at the anode and the pure copper at the cathode. And the electrolyte is copper sulfate solution. This one is really important. The impurities with the copper, what will happen to these impurities? Some of them will fall to the bottom of the beaker and some of them will be changing into ions, will dissolve into ions. We have 2 impurities with the coppers, silver and zinc. Arrange them according to their reactivity in the reactivity series. So the most reactive is the zinc, then copper, then silver is the least reactive. So you know that metals react by losing electrons. So the more the reactive is, so it has more tendency to lose electrons. So the zinc is the most reactive. It will be able to lose electrons more than the copper and silver. So it will change to ions. But the silver is the least reactive, so it will fall in the bottom in a form of sludge. The silver impurities, it will fall to the bottom. Because it is less reactive than copper. But the zinc impurities will dissolve into the solution as ions because zinc is more reactive than copper. A student electrolyzes aqueous copper sulfate using the apparatus shown. Actually, these are carbon electrodes, so they are inert. Oxygen is formed at the anode. Write an ionic equation for the reaction at the negative at the cathode and include the state symbols. So the copper ions will gain electrons to change to copper atoms, and the copper ions are aqueous. The copper deposits are solid. Describe what the student observes at the negative. Actually, the copper is pink-brown deposits. Give two other observations which the student makes during the electrolysis. In this scenario, in the inert scenario, the blue color of the solution will fade, and this is really important. Why? Because the concentration of the copper ions will decrease, because the copper ions are removed at the cathode, but they are not replaced. So this means that the concentration of the copper ions will drop, and this will cause the blue color to fade. So the first observation is the solution becomes paler or less blue. And we know that this happens because the concentration of copper ions drops as they are removed but not replaced. The second observation is that there is bubbling at the anode because we have hydroxide ions that will be discharged at the anode. So solution, there is bubbling or bubbles at anode. What difference would the student observe at the positive electrode if an aqueous copper sulfate was replaced by concentrated copper chloride? So the difference is that there will be green gas instead of the colorless gas because the chloride ions will be discharged at the positive electrode. So green gas would be seen at the anode. The last question, what is meant by the electrolyte? Actually, the electrolyte is the liquid in which undergoes electrolysis, and it must be ionic in the molten or aqueous state. So it is molten or aqueous ionic compound that conducts electricity and undergoes electrolysis. Describe the electrolysis of concentrated aqueous potassium bromide. Actually, there is water with the potassium bromide, so we have 4 ions. Don't forget this. If it is molten, so there are 2 types of ions only. Now we have 4, the potassium, the bromide, and the hydrogen and the hydroxide. These ions will be attracted to the cathode. The one that will be discharged is the less reactive, which is hydrogen, forming a hydrogen gas at the cathode. Bromide and the hydroxide will be attracted to the anode. Actually, if the halogen is concentrated, so the halogen will be discharged, forming a bromine gas. And the ions that will not be discharged will remain in the beaker, forming potassium hydroxide. Alkaline solution remains in the beaker. So the ionic half equation at the cathode, hydrogen is formed at the cathode. Bromine formed at the anode. And potassium hydroxide is the alkaline solution remained. If it is molten, name the product at the cathode if it is molten. So we have two types of ions only, K plus and Br minus. The one that will be attracted to the cathode, the negative electrode, is the potassium positive ions, forming potassium deposits. Thanks for watching.